Hey guys, welcome back to another video. As you can see here, I have the Z-axis completely assembled and we've reached another major milestone in the project. So originally I was going to assemble the Y-axis linear rails and the X-axis first, but after giving it some thought, it made sense to just complete the machining of all the parts. Assembled the Z-axis here. It's starting to look great now. There's not a lot more to do, in all honesty. I've just got to bolt them rails down and then we can start installing the hardware. So what I'll do now is I'll jump into Fusion 360. I'll talk you through the Z-axis briefly so that you have a good idea of how it's assembled. It's probably the most complicated part, I'd say, of the whole thing because there are so many parts so close together, and it does require a lot of drilling for the holes here on the back plate and the motor plate. So let's dive into Fusion and I'll show you that. Okay, so first thing I thought I'd do here is jump into Fusion 360 where I designed the machine and just show you what the aim of today's video is to get this built exactly as you see it here. I'll hide the spindle for you. So what I aim to achieve is to assemble the whole Z-axis, not just the frame but actually install all the parts as well. That'll ensure everything's working and moving nicely with no binding. So I'll be confident then mounting that directly to the X-axis. So let's look at the back here. So in terms of the components we'll need, this is quite a simple design actually. It's not as complicated as you might think. So we've got these standoff bearing blocks here on the back, and they're also on the Z-axis here. There are 4 in total. They're all the exact same dimensions. And the goal of those really is, as you can imagine, to stand these plates off from the bearing blocks. So if I show you the X-axis here, what you can actually see is by having these bearing block standoffs, we're allowing the ball screw to be fitted behind the machine. Same goes on the Z-axis here. You can see that the ball screw is tucked in behind. That was a critical design decision, I think, to simplify the machine and also reduce the cost, because typically you will see the ball screw of the X-axis on the top of the machine or even behind, but what that does is it increases the size of the parts you need. For example, the side plates would need to be a bit larger. We'd also need another plate to run across the top, and these big thick plates are costly. So my reason for not doing it that way was, as I said, reduce cost, simplify the build, and all these do, as you can clearly see, is bolts go through here, pass through each of these parts and bolt straight into the bearings. If I hide the X-axis again here, the only other thing we have is if I hide the spindle mount, we've got the Z motor plate, which is straightforward, does what you saw there. It just holds the spindle bracket and allows the Z-axis to move up and down. Nothing too complicated there. Behind that, simple, we have the bearing blocks, as I said, bolt to the rails. And we have the part of the back there which obviously couples the Z-axis plate to the ball screw, and then the linear rails are bolted onto this obviously with all the holes marked out. And the only other part is this top Z-axis motor plate. So if you remember before when we were drilling those large 30mm holes, I have one more to drill here, but this is only 10mm plate, which should make that process a bit simpler. So that's going to be the Z-axis. I'm going to get these as accurate as I can. When the machine's running, what I'm tempted to do is potentially upgrade some of these parts to steel or even stainless steel, because I can then CNC those on the machine, which will make them more accurate. So in terms of the very first build, this is going to be perfect. It'll be just what I need to get the machine functional and to test everything. You know, the great thing about having a capable machine is you can make upgrades for it, and that's exactly what I plan to do. So this is looking great. What I'll do now is I'll head over to the bench, I'll show you the real physical parts, run you through some of the technical drawings again, and we'll build this thing. So exciting stuff, let's go. Right, so here we are back at the machine, and as you've just seen on the PC, I have the corresponding parts here to actually build the Z-axis. This is everything left in terms of the frame that we need to build. There are no other components aside from the linear rails and the bearings and all the actual hardware that we need to install. So we're kind of getting toward the end of it now. It's getting exciting. So here are the bearing block standoffs. as I showed you on the PC there. So these again actually have a bit of cutting tolerance to them in terms of their length and width, but that isn't too problematic because in terms of the length here it doesn't really matter as long as the holes line up with the plate. Same on this one. For the issue with the width, so they're actually about 51 wide. As you can see there, it's supposed to be 170 by 50. It's actually about 171 by 51. In terms of that, what I'll do is I'll mark a center line here and I'll reference all my measurements from the center line. If we do the same on all the other components, it won't matter if you're sort of a mil off either side because you're always referencing the center lines, and that's key when your lengths are a little bit larger or potentially even shorter than you want. So this here is the Z-axis backplate, which eventually secures on to the X linear rails. This one here is that motor bracket on the very front where we have that spindle mount connected to, and this here is the Z-axis motor plate, which will obviously sit up on the top. Just like on all the other components, I have the technical drawings with a technical reference which you can find on the spreadsheet. So again, this one's simple. The bearing blocks are simply just holes that a bolt will pass through straight into the bearings themselves. Nothing complicated there. Just got to do 8 holes on 4 of the parts. This one is probably the most complicated part of the whole thing in terms of how many holes need to be drilled. I will say though, a lot of these holes are the linear rails themselves, and I probably won't actually do them straight away. I'll do what I've been doing before where I'm using jigs to mark out the holes, because that needs to be accurate. They need to be accurate, as I said. This is going to be the same method that I use with the Y-axis here, where we move the gantry forwards and backwards to line it up. I'll be moving the Z-axis motor plate up and down to line those up. So the holes I'm going to drill are the ball screw bearings. I'm also going to do the holes here that decouple to the bearing standoffs. We've then got the plate here for the Z-axis motor mount. This one again, pretty straightforward. As I've specified here, this is essentially a mirror, so all these measurements here are reflected on that side, just opposites obviously. Pretty straightforward. And here we are, the final one we've got here is for the Z-axis motor bracket, which is this piece here. As I said, that's got one more of those large 30mm holes, a couple of straightforward holes here, and these holes for the motor are threads. They're M5 threads. So we're going to have to drill M4 holes and tap them. Alright guys, you can see here I've got all the pieces for the Z-axis. I've marked out and drilled all these pieces. I've just marked out the motor plate and the back plate, and I'm going to drill those shortly. However, one of the first things I'm going to do is drill some holes here in the spindle mount, because that needs to mount on here, and in order to get the holes for that, I want to use this as a means to mark them out, just like we've done throughout the project. So I'm going to go and drill holes in this exactly halfway, and then use that, as I said, to line up, mark the holes out, tap them with a punch there, and then I could go and drill all the holes for these parts. Really starting to get there now. We're approaching the end. These are the last parts that I'm going to have to really machine, aside from bolting the rails down, but it's all looking good. So let's go and drill the holes for these parts. So we're back here after marking out and drilling out our holes on the spindle bracket. I've done these as 8mm holes. So what I'll do now is get this all lined up, and I'm going to use a base plate to ensure that we get this level, because obviously we need to make sure that the spindle is perfectly level and 90 degrees with everything else. We've got to do what we can here to get this centered in terms of its X position. Make sure that we're exactly parallel with this plate, and then mark out our holes just like we've done before with a little drill bit. I'll clamp these on. Okay, so you can see what I've managed to do here. Again, use a flat surface as a reference to bottom out the spindle bracket with the bottom of the Z plate, and then the same thing this side. We want them to be even so we get it centered. Another thing worth mentioning here when you're getting this lined up, remember, if we're using a block like this to ensure it's flat, you're also relying on this part being perfectly flat. So what you want to do is take a square and make sure that you check that this bottom face here is 90 degrees and it's not sort of cut at an angle. That way, when you line this up, you'll know that it's accurate. When the machine is actually built and we're going through the setup process, these are things that we're going to have to tweak anyway, so there'll be a point where we loosen some of these bolts, check how parallel we are to the y-axis and the x-axis, and then we can make adjustments based on that. But as I said, get it as accurate as you can here, and the likelihood is that when it comes to the calibration phase, you won't have much adjusting to do. So we've got this bolted on. Just wanted to get that on there and test that it's sitting correctly, and yeah, that's great. So what I'll do now is I'll take this off, drill out all the rest of the holes. Same on the big plate here, I'll drill these out. Then we'll start assembling it, and then we can use this piece to align the rails on the Z-axis. We should be able to start assembling the entire Z-axis of the machine, which is very exciting. Okay, so here we are with all the Z-axis parts machined and ready to be assembled. The only remaining thing to do on this piece here is to do the M6 taps on the ball screw bearings. Got the small one on the bottom here and the large one on the top. The holes for the linear rails do still need to be added, but as I said, I want to get as much of it assembled as I can, and then use the up and down movement here of the Z-axis as a jig to mark out those holes. So that's what I'm going to do now. I'm going to start assembling the Z-axis, and what I'll probably do as well is give these a little bit of a sand down. I'm not going to do nothing too major because I want to keep these as flat as possible. I'm just going to clean them up. I'm not too bothered about the lines and stuff on the plates themselves. I don't want to take too much material away. But yeah, I'm just going to clean them up and start assembling the Z-axis. see there, we've got the bearing block standoffs bolted to the bearing blocks themselves with the motor plate on the front. Those 3 holes there are obviously for our spindle mount. These holes here are for the back side, which that'll sit in. So what I've got here are some M5 20mm, which are going to sit in here. Again, I'll probably use some kind of spring washer when I assemble this for the final time. Right now I'm just making sure everything fits basically. So if I flip this up again, we've now got our coupler there to connect to the ball screw. I may need to change the orientation of that. I haven't double checked that here with the actual ball screw, but that's the position that it's going to sit in. So now, like I said before, we have a similar setup here on this back piece, because these have the same effect on the x-axis. So they're going to bolt to the back of this plate, and then what we can do is we'll loosen these back up a little bit, slide the linear rails through these, and then we're going to use this as a jig on here to mark out the spacing and the holes for the linear rails themselves. These are 350mm in length, which gives us plenty of travel here for our large spindle. So what I'll do now is I'll go ahead and get this part installed. There's still a couple of holes I need to drill, which I forgot about. So if I put this aside for a moment, this actually goes this way around. So this will mount like this. It doesn't really matter which orientation we decide to use here. The distance is all the same. But then we've got this plate that needs to go up the top like this. So just like before, what I'm going to do now is grab those clamps, get this clamped on, mark out the holes in the end here, drill them out, tap them, and then I'll bolt this to this piece. That way I know I have a good reference at the end there, because this linear rail needs to make contact with the top up there, because that's its furthest travel point. So we should end up with something that looks a little bit like this, thereabouts, but obviously nice and parallel and straight. So I'm going to go and do those holes now. I'll be back and we'll start to assemble the rest of this. Alright, so here we have the Z-axis backplate with the NEMA mount on top, and it'll go in this orientation like this. We also have the Z-axis ball screw here, which will sit just here in this position, and like I said before, this will move obviously up and down, allowing the Z-axis to travel. What I'm going to do first of all is, just like we did on the motor plate, I'm going to secure the X-axis bearing block standoffs to the back, just like we did there. So these are going to go here, like this. So I'm going to go ahead and do that now. There we go. I'm not going to tighten them up too tight yet, because when it comes to installing them on the X-axis, loosen them a little bit so that we can get the rails on there nice and parallel. So that's all we want for now. We've got them on, starting to look really great. Again, we can put the coupler on for the ball screw, which I'm going to do now. So remember, just like before, these have threads already in them, so we've just got holes here. So simply pop these bolts through. There we go, starting to come together now. This is quite a nice bit of work here. I think it looks really good. It's going to look even better obviously when we've got this part on, and you can see now we're pretty close to the end in terms of constructing this. All I really need to do is put the rails through the bearings and kind of line it up and mark out my holes, and then it's going to be a case of tapping the holes for the rails and bolting it all together. So this is going to be fun. You can see how smooth this is. I'm actually going to bolt this down. So in order to get this lined up here, if you remember, I need to figure out which way that actually goes. And my guess is it's going to be the opposite way to the way I've got it, because that's generally how it goes. Yeah, of course, it actually needs to go the opposite way. So what I'll do here is just flip this round. It won't take me a second. Okay, so now what I'm going to do is loosen these back up a little bit, like I said before. Only enough so that they can wiggle just a little bit. You want them to have a little bit of play like this. That way you'll make sure that they go onto the rails nice and straight. I'm just going to do each bolt. There we go, see, a little bit of play like that, nothing more. So I'm going to flip it upside down. I'm going to do this side first. So with these in particular, you've got to be very careful. Gently slide this off. Be careful that none of the bearings fall out. What you can actually do is leave it in and just slide the rail straight in, and that'll push the plastic plates out. So I'm going to do that. So you can see I just push them in gently. There we go. So you can see now this is mounted on the rail. Put these safe, because you probably need them later when you take them back off. So you can see that's on there nice and straight now. Flip it back over. Now what we want to do with this positioned halfway either side here and even amount each side, now we tighten them back up because we know that these are going to be in parallel. Tighten them up evenly, corner to corner. There we go, that's that side done. You see it moves nice and smoothly, and you can really feel just how rigid this is. There's no movement at all. So we'll do the same now on the bottom rails there. Just loosen them up. Make sure you've got a bit of wobble on each. Perfect. Gently push the rails. It also helps to clean these a bit if they are dirty. Mine are okay. I'm going to wipe them anyway. It just prevents dust from getting in here. Just gently push it on. There we go. Put them safe. So the ball screw will insert in there, as you can see. Pop it in. Let me just make sure that I have the right orientation. It's starting to get heavy now. So we've got that at the bottom, that's correct. There we go. I'm going to put a couple of temporary bolts in there. I'm only going to put 2 in for now because this is just for testing. Once everything's lined up, I'll take it all back apart, and obviously I'll add in some Loctite and stuff to avoid these coming undone due to the vibrations of the spindle. So there we go, that's on, nice and rigid. You can see now that if I spin this, it's going to move, and that's what's going to drive our Z axis up and down. So at this point, this would flip around like this. So I want to move this up a little bit, roughly toward the top where it's going to go. About there, see? And I want to pop the bottom one on as well. These can be tricky to get on sometimes. Some persuasion always helps. Okay, so flipping this over, we should have something like this. So now this is starting to look great. So we want to move this up into the correct position, and we can do that just by winding it until it moves into the right spot. So we've got that bolted down. Now we've got a sort of base point here. You can see that's where we're going to come through there, and what you can do is attach this to the drill if you want to move it up and down easier. So I show you that. So rather than wind it by hand, if I spin this backwards, kind of fun to do that actually. So what we'd be looking to do now, as you can see, is move this up to this position at its highest point, where we can still access the holes here for the linear rails. Now we have the exact positions that we need to define our holes here for the linear rails. So now what we can do is start to tighten these up, make our markings for the top holes. We then drill those, bolt them in, push it all the way to the bottom, and these will then line up down here, and you'd mark your holes at the bottom also. And then once you've got the top and bottom holes, you can mark out all the other holes and just tap them, bolt them in. It's as simple as that. And if you do it right, you should have no binding at all, because we're using this to determine our furthest outward points, which should have a smooth transition at all points between those two. Let's get this bottom bearing on as well. So now that we've got both ball screw bearings on, this can't fall out, it cannot move. So you can see we've got the full range of travel here, which was partly why those bearing blocks are so important, because if I come back, you can see that we've got just enough clearance, probably 1/2 mil, to pass over that, which is all we need. So in terms of the design, I did what I could to conserve your sort of working area while trying to simplify the design by using these. So again, when doing this by hand, one of the perks of drilling slightly larger holes, in this case these bolts are M5s, but the holes I drilled in both the standoff and the plate are 5.5s, and if you look, that gives me play. So if you were to drill 5mm holes there and you happen to get them out of line, you're pretty much fixed to that point. Whereas here, because we know there's inevitable human error, by doing this and having wiggle room, I can find the sweet spot and then tighten the bolts in place. And once we've got the rails down and the bolts tightened, it's not going anywhere after that. A really good way to test this out without actually drilling any holes is to clamp these in place. So you can see here, when I pull this to the furthest back position, I've got them clamped there, which is where I drill the holes. And then you can keep an eye on this end, and you'll see that you should find a good position where you don't have any movement. So what you don't really want is too much of this going on. A little bit's probably okay because it's adjusting to position, but if you've got major sort of bending inwards or outwards, it means you're probably going to get some binding, and you've made a mistake somewhere here. So you want minimal binding. This is actually looking really good here. I'm quite happy with this. So as I said, my next step would be to bolt these in place, and then come to your furthest downward point here, up the top. I'd bolt down here, and then obviously I can bolt here as well. And you just want to move this around until you can eventually bolt all the holes. You can potentially drill and tap in place here as well, because this just acts as a vice basically, and it all holds it together. The difficulty is, of course, getting a drill, the right bit to go in there. And obviously if we're tapping by hand, you won't have much room to turn your piece here. That being said, this isn't a very thick plate, and we'd probably be able to do the taps with the drill. Alright guys, so we're back here, it's the next day, fresh eyes, and I wanted to save this part where I wasn't feeling too sort of worn out by doing the rest of it. You always want to take your time with this part, because obviously if you drill the holes wrong, that's going to be quite problematic, and you're going to have to redo the back plate. So as I said before, what we're going to do, bring this down to its furthest point like I've done here, and then we're going to make sure that our rails are as centered as possible. So what we'll be looking to do here is simply just measure up and try and get the same distance on each side. So here we have 11mm, and here we have just over 11mm, so it needs to come over a little bit, ever so slightly. Now we have 11.5, a little bit more, 11.5, 11.5. So that's the position we want to keep these in. So when you've got them centered up, what you can then do is clamp them in place at the top here. That's just going to hold them temporarily while we mark out these other holes. One thing that I have mentioned before is that the holes to bolt down the rails are M6. So this is an M6 bolt and it'll fit all the way down and touch the bottom plate here. The problem is that the cap head doesn't actually fit in there. So whether that's a manufacturing error on the side of the rails, I don't know. However, that does mean that we're going to have to use M5 bolts to bolt these in place. Now luckily I saw this ahead of time, and when I ordered my bolts I ordered the same amount of M5s as I did M6s. So that could be a potential cost saving for you if you do the build. So these are 20mm M5s. Now the reason that's relevant is because we can still use a 6mm drill bit in there to make our centre hole, because what you wouldn't want to do is put a 5mm bit in there where it can wiggle around. Then obviously when you go to tighten it up, it's going to shift. So use a 6mm bit, mark out your 2 holes, but obviously we're going to start at this side. And then you can go away, drill those 2 holes, come back, put everything back on, bolt those down. Then we're going to adjust this way, mark out those holes, we'll drill them out, then come back, bolt them in, and then we'll mark out all the other holes, just like we've done for the rest of the project. So I'm going to go ahead and do that now. Okay, so I've marked my holes now with a 6mm bit. I'm now going to take everything back off. And this whole thing will lift up easily just by undoing the bearings here, and then this whole plate will lift, so it's not too hard to keep assembling and reassembling. So here we go. If I now lift this straight up, the whole thing should pull away. I can just place it on the side. You can see my holes marked out there, so now I'm going to punch those and we'll go and drill them out. Okay, so they're in place. What we'll do now is bring this back down as far as we can to the position it was in earlier. And now we can go ahead and bolt those first 2 down. So in this case, like I said, they're M5s. So they should just drop straight in the holes. And then we bolt them in. So we're going to tighten them just a little pinch, just because this is likely going to move a little bit, and we want to allow that so that we can do the adjustment up here. So there we go, they're in place. Now what we want to do is bring this as far up as we can, just like before. So there we go. Probably go a little bit more. Okay, so what I'm going to do now is really tighten these bottom ones up, as tight as I can. Guys, so here we are. Here is the completed Z-axis assembly. It cleaned up extremely well, as you can see. I'm very happy with how it's turned out. The build process was seamless. Such an easy process thanks to the way I was able to design it in CAD. I saw a lot of the potential problems beforehand during the CAD design, which made this process just so easy. So that's one of the benefits of CAD. I knew exactly what materials I needed, how they'd fit together, and when it came to putting them together, it was just straightforward. This motor bracket here, if you go back and look at it in the previous part of the video, looked a little rough due to the way it was manufactured, but I managed to clean this up really nice with a sander. Looks like a nice polished aluminium part now. I think it looks fantastic. So I've got this hooked up to the drill here, and I can show you the travel up and down. So there we go, guys, we now have a successfully assembled Z-axis. As I said, it's starting to look great. I give a couple of demos of it working by attaching the drill. And I'm really excited now to get all the hardware installed in here. As I said, next steps are going to be getting the X-axis linear rails on, get this attached to that, and then we're going to use the whole thing as a jig here to do the Y-axis rails. And once that's been completed, we're done. So all I'll have to do then is install the hardware, get the electronics running, and we should have this thing running very soon. As always, thank you so much for watching. Appreciate your time today. If you enjoyed the video, give it a thumbs up. Consider becoming a website member if you'd like to support these projects. And I'll see you in the next video.